Well, welcome back. In this lesson, we are going to focus in on constant rates of change. And to start off, let's go ahead and just talk about a little bit of vocabulary we need to clarify here. Linear relationships are relationships where the graph is a straight line and there is a constant rate of change. That constant rate of change is called the slope. And when the rate of change between any 2 points in a linear relationship is the same, we call that a constant rate of change. So our objectives for this lesson is to be able to identify proportional and non-proportional linear relationships by finding that constant rate of change. Here's an example. It says the balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? If so, find the constant rate of change, and if not, explain your reasoning. Well, the balance is decreasing in each of these transactions by $30, and the number of transactions is increasing by $3. Excuse me, by 3 every time, the number of transactions. It's not dollars, excuse me. So to find that constant rate of change, it would just be the ratio of the constant change in the balance divided by the constant change in the number of transactions. So we would have negative 30 divided by 3, which gives us negative 10. And our interpretation of that, our explanation, means that on average every transaction involves a $10 withdrawal. Here's two more examples to work out. One's cooling water and the other is wrapping paper. Let's take a look at what's happening with the temperature for the cooling water. We start at 95 and go down to 90, so that's a decrease of 5. From 90 to 86, we go down 4. And from 86 to 82, we go down 4. And then our time in minutes is increasing by, it looks like it's going up by 5 for each one of these intervals. 10 to 15 is an increase of 5, and 15 to 20 is also an increase of 5. So if we look at these ratios, on the right-hand side, we do not have a constant ratio, or a constant change, so therefore this is not a linear relationship. Let's go ahead and take a look at the wrapping paper example. In the wrapping paper, we go from a total cost of $8.50 to $17, so that's an increase of $8.50. And then from 17 to 25.50, which is an increase of $8.50. And then from 25.50 to 34, which is also an increase of $8.50. On the other side, we're going up between each of these intervals by 2. We're gaining 2 rows in each scenario. So this is a linear relationship, and the rate of change would be represented by 850, the positive 850, divided by positive 2, which gives us a rate of change of 4.25 dollars per roll. Okay, dollars per roll. So that is definitely a linear relationship with a constant rate of change. In this example, we have the cost of pizza versus the number of pizzas. Using the graph, we're going to find the constant rate of change for the cost of each personal pizza ordered, and we will interpret the meaning. So first we're going to choose 2 points, and I chose the points 1, 3, and 3, 9. So the change in cost is $9 minus $3. The change in the number of pizzas is 3 pizzas minus 1 pizza. That gives us a change of 6 over 2, which can be represented as $3 per pizza. And that is a linear relationship. Graphs is a straight line, and the constant rate of change is 3. Here's another example, a trash pickup project. Find the constant rate of change for the time it takes to complete a highway trash pickup project for each number of volunteers in the graph, and interpret the meaning. So first of all, we need to take a look at what our coordinates of each of the points are. And the first one, the x-coordinate is 8, and the y-coordinate is, it looks like about 75. In the second point, the x-coordinate is 16, and the y-coordinate is 60. In the third point, we have an x-coordinate of 24, and a y-coordinate of, it looks like 45. And in the last coordinate, we have an x-coordinate of 32, and the y-coordinate is 30. So once we have those defined, then we can go ahead and take a look at what's going on. If we look at the change in the y-coordinates from 75 to 60, that went down by 15. And then from 60 to 45, again, a decrease of 15. From 45 to 30, the same decrease of 15. Take a look at the x-coordinates. We started at 8 and went up to 16, so that increased by 8. From 16 to 24 was an increase of 8, and from 24 to 32 was also an increase of 8. So therefore, we can say that our rate of change, this is linear, and our rate of change can be represented by negative 15 divided by positive 8, and that gives us a net rate of change of negative 1.875, and that's the time in minutes per volunteer. So proportional linear relationships are when two quantities have a proportional linear relationship only if they have a constant ratio and a constant rate of change. We've been finding the constant rate of change in the last several slides. We also need to look at the constant ratio. If both of those exist, then it is a proportional linear relationship. So let's go ahead and take a look at what some of those problems might look like. Here's a graph of the degrees Fahrenheit versus Celsius with a bunch of data points. And using that graph, we want to determine if there's a proportional linear relationship between the degrees Fahrenheit and Celsius. Well, first of all, if we look at the changes in the number of degrees in Fahrenheit, we find that those are increasing by 5 degrees each time. Those are the y-coordinates. And the degrees Celsius are our x-coordinates. Those are increasing by 9 degrees each time. So our constant rate of change is the change in the y variables over the change in the x variables, which gives us a constant rate of change of 5 over 9. So we do have a linear relationship. We can see that by the graph, that it graphed as a straight line. To determine if the ratio is constant, we need to take a look at each of those data points and see if we have the same ratio between the data points. So we're going to take a look at 37 divided by 9, 42 divided by 18, 47 divided by 27, and 52 divided by 36. We're just dividing each of those data points, the y variable by the x variable. So we can see that we do not get a constant ratio, so therefore this is not a proportional linear relationship. One of the shortcuts I'll tell you, if you happen to be one of the ones that's actually listening to the video and not just watching it, is we can tell right away by looking at the graph whether or not it's a proportional relationship based on whether it goes through the origin or whether it has a different y-intercept. If it goes through the origin, it is proportional, but if it has a different y-intercept, it is not a proportional relationship. So that's a quick way to identify that. Here's another example. It says, determine if there's a proportional linear relationship between the weight of an object and its mass. And in this example, we're going to go ahead and look at the weight in kilograms versus, the weight in pounds versus the mass in kilograms. And we've got several data points listed here. So let's just take a look at what's going on between the y variables. We go from 36 to 27, and that looks like a decrease of 9, okay? And 27 to 18, whoops, I didn't draw that very well. Let me go back and draw that a little more accurately because it looks like I'm going to the x variable, which is not what I want to communicate with you. So we're going from 27 to 18, which is a decrease of 9, and from 18 to 9, which is also a decrease of 9. So we're consistent with the y variables. So let's check out the x variables. We go from 80 to 60, which is a drop of 20, 60 to 40, which is another drop of 20, and 40 to 20, which again is a decrease of 20. So our constant rate of change would be represented as negative 9 for the y variables over negative 20, which simplifies to, let's see, just positive 9/20. That would be our constant rate of change. Our constant ratio, to find the constant ratio, we're going to divide each of the terms by the y variable by the x variable. So we should get 9 over 20, and that should equal 18 over 40, which should also equal 27 over 60, which should equal 36 over 80. And if you were to go ahead and try any of those, you would see that you would get the exact same ratio of 9 over 20, which is, when you divide that on your calculator, your constant ratio is 0.45 in decimal. All right, here are, I believe we have 6 problems here. Yep. Go ahead and work on these 6 problems and see if you can come up with the answers, whether you're determining whether it's linear. The second set, numbers 3 and 4, finding the constant rate of change if it exists. And then exercise 5 and 6, you're referring back to exercise 3 and 4 right here to determine whether or not those are proportional relationships. So go ahead and work on those 6 problems and bring your answers to class, and we'll see you next time.